So what if we could actually solve our planet's energy crisis for good? Today, we're going to dig into one of the most incredible, most audacious engineering ideas ever put on paper, a plan to build a power plant that literally wraps around the entire moon.
You know, for as long as we've been around, we've been dealing with limited resources. It's a constant struggle. But the dream has always been to break free from that, to find an energy source that's not just clean, but truly, completely unlimited.
Well, what if that perfect energy source has been staring right down at us every single night? This wild proposal says we need to look up, about 239,000 miles away, to our closest neighbor in space for the answer.
Okay, so let's get into what this actually is. The concept is called the lunar ring. And yeah, it's pretty much exactly what it sounds like, a gigantic belt of solar panels built to circle the entire moon.
So the core idea here is to build this continuous band of solar cells wrapped all the way around the moon's equator. We're talking about an 11,000-kilometer-long structure. To put that in perspective, that's roughly the distance from New York to Tokyo, and it would be soaking up constant, unfiltered sunlight.
And the scale is just mind-boggling. The plan kicks off with a belt that's a few kilometers wide, but the end game, the ultimate vision, is to expand it to 400 kilometers wide. That's a ribbon of solar panels wider than the entire country of England. It is a true megastructure.
So why on earth would we go to all this trouble? Well, the payoff is a total game changer. Think about it. Here on Earth, you've got clouds, you've got weather, you've got nighttime. They're all constant problems for solar. But the moon? No atmosphere. That means you get 24/7, non-stop, completely predictable solar power. The goal here isn't just to add a little juice to our grid, it's to power the entire planet and create a completely clean energy society.
Okay, so generating all that power on the moon is one thing. But then you have the next giant question: how do you get it all back down here? How do you build an interplanetary power grid?
It's basically a four-step journey. First, the solar cells capture the sunlight. That power is then sent through cables to these massive transmission stations. And here comes the really sci-fi part. That energy gets converted into focused beams of either microwaves or lasers and literally shot across space. Then, down on Earth, huge receiving stations catch those beams and feed the power right into our grid.
Now this is really cool. There are two different ways they propose to send the power. Microwaves are like the workhorse. They can punch right through clouds with about 98% efficiency, so almost no energy gets lost. Lasers, on the other hand, are the precision tool. They're more concentrated, which is perfect for places with clear skies. And get this, even the waste heat from the lasers can be captured to generate even more power. It's like having two different tools for one incredible job.
And this gives you an idea of what these ground stations might look like. Over on the left, you've got the concept for the microwave receiver, a massive 2-kilometer-wide grid they call a rectenna. And on the right, for those super-focused lasers, you've got this slick offshore facility which keeps the footprint on land as small as possible. I mean, each one of these is an engineering marvel by itself.
This all sounds absolutely incredible, right? But it brings us to a huge, glaring challenge. How in the world, or I guess how on the moon, do you actually build something this massive?
I mean, just let that number sink in again. 11,000 kilometers. You can't just ship all the materials from Earth. It's not just insanely expensive, it's pretty much impossible. So what's the plan?
And here is the genius part of the whole plan. You don't bring the materials from Earth, you build with the moon itself. The idea is to mine and process the lunar soil, the regolith, to create almost everything you need right there on site. We're talking concrete, glass, even the solar cells themselves. You can even extract vital stuff like water and oxygen. The moon becomes the factory.
So who are the construction workers? An entire army of robots. But here's the twist. They wouldn't be totally autonomous. The plan calls for a teleoperated workforce. You'd have human operators back on Earth controlling them in near real time, working around the clock to mine, manufacture, and assemble the whole thing.
Now, this was never going to be a short-term project. The original proposal laid out this multi-decade roadmap, with the 2020s being all about pilot programs on the moon's surface. The super ambitious goal was to actually start the full-scale construction by 2035.
All right, so let's zoom out to the big picture. What's the ultimate vision here? What does this kind of project actually mean for our future? You know, the goal is nothing short of a complete transformation of human civilization. It means we finally, truly end our reliance on fossil fuels. It means we could unlock a real hydrogen-based economy. It means providing limitless, clean energy to every single person on this planet, no matter where they live.
And this chart just drives that point home. The forecast for our global energy demand back in 2030 was around 17 billion tons of oil equivalent. That's a staggering number. The lunar ring isn't designed to just meet that number. It's designed to blow right past it, creating a new era of energy abundance.
The Japanese construction company that first came up with this idea, Shimizu Corporation, really said it best. They saw this as more than just a power plant. They were chasing the ultimate dream of all mankind. And this final image, wow. It just captures the entire vision perfectly. Imagine standing on the moon, on this monumental achievement, and looking back at our home planet, glowing, fully powered by clean, constant energy from the sun.
Look, the lunar ring is, without a doubt, one of the boldest ideas ever imagined for our energy future. And it really makes you wonder, right? Will these kinds of incredible visions just stay in the realm of science fiction? Or will they become the heritage that we decide to build for tomorrow?